Today, it's very similar to yesterday. You mash up two figures, but there's no like deciding line between it that says, oh, that's a this and a this. You guys got to find that line and break it up yourself. So if you take a look at the first problem here in A, I don't know what to call that figure. I'm going to call it a composite figure. Why a composite? Because hopefully you guys have the ability to break it up into figures you are familiar with. Figures that we've already talked about the area of. So I just want one person to make a class decision for us because there's different ways we could break this up. Tell me where to draw a line or lines, how you want to break this up into figures you do know the area formula for. All right, and then we'll attack it and find the areas of each piece. Big job coming up here for number 15. How do we want to break it up, Henrik? Use your big boy words. Throw in at least a vertical or a horizontal line for me.
Okay, so the vertical line with 12 and 8 down to 15 and 5. Oh wait, no, it's diagonal line.
You want this line? That one? Okay, I was going to say, you want anybody, I don't know. I think you're just overthinking this. I don't do charades, so.
Parallel to the 12.
Yeah, nice word. Nice word. All right. I'm with you now. To what?
To down to the bottom.
Parallel to what side?
12.
Thank you. All right. Whew. We got it now. So what'd you divide it up into? You divided it up, so I'm assuming you would have been like, all right, I got a rectangle and a trapezoid. Yep. You all right back there now, Henry? Whew. Rectangle formula, length times width. Could somebody please provide the length and the width of that rectangle that Henrik has created? 11. Length and width of that rectangle. 12 and 8. So the area of the rectangle should be 96. If you don't know it, don't say I don't know. Look back for it in your packet. Area of a trapezoid. Area of a trapezoid. Here you go. 1, Maddie.
1/2 times base 1 plus base 2 times height.
There you go. Good. 1/2 the height. Base 1 plus base 2. Okay, let's see if what happened there, huh? Let's see if we can get all those numbers for us. So here we go. Okay, 4, here we go. There's that trapezoid. What's the two bases? 12 plus 5, and here we go with the height. Where'd you get the 7 from? If that's 8, this is 8. The whole side was 15. Subtract them, you get 7 for the height. And what do we have? That one's a 0.5er, isn't it? For that area. $59.5. So my total area, add them together. I got 96 plus 59.5. Total area, 155.5 square inches. Yep. Please do not go on to the next one because I have a follow-up question. Pens down. Pens, pencils down. I got a follow-up question. Everyone all right on how we got here? What's up, stud?
So why is the height 7? Why wouldn't it be 12?
Well, the bases in a trapezoid have to be parallel. And those are the only two lines that are parallel. All right, and then the side that's perpendicular coming from one of the vertices, so this forms a right angle, so that tells me that's got to be the height. Now you could you could also do this if you wanted to here. Draw that in and find it. That's the height too. Okay. All right, here's my question. Let's just play along with me. That's a parking lot. The original figure is a parking lot. I want to get it paved. Okay, I want to get this parking lot paved. So I hire a company, and they will charge me $1.25 per square inch. How would you find how much they're going to charge me? And I do this with you because this is the same thing I told you on day one of this unit. I do not want you just to guess whether you divide or multiply here. I want you to have a way to figure out, okay, this is definitely division. This is definitely multiplication. Okay, what are your thoughts, Thomas? So you're a multiply guy here. Okay, I may have some divide guys in here. You just don't want to say it. Okay, or maybe you're just unsure either way. Okay, the way you could figure it out, and here's what I'm going to, if you guys are on the fence, which way to do, is to set up a quick proportion. I'm going to charge you $1.25 per what? 1 square inch, right? How many square inches do I have? So where should that 155.5 go? Shouldn't you be matching up your units? So square inches on the bottom, I should keep square inches on the bottom. So what are you going to end up doing with the 155.5 and the $1.25? In this case, you're going to multiply it. Okay, and think about it this way. Ready? Ready? I got 1 square inch. How much are you going to charge me? $1.25. I got 2 square inches. What are you going to do? 2 times $1.25. I got 3 square inches. What are you going to do? Okay, you keep multiplying, don't you? Well, I don't have those. I have 155 square inches, so you are going to end up multiplying it. But if worse comes to worse, set up a proportion where the units are across from each other. All good. Yes, Anthony, go.
What would be a problem where you have to divide?
Okay, problem, let's see, in this case, okay, ready? Let me just change it up now. Instead of it being a parking lot, it's a field. Okay, it's a field, and I want to get it seeded. All right, and I'll tell you that 1 bag of seeds covers 50 square inches. How many bags am I going to need? Okay, so now you can say, all right, 1 bag for 50 square inches, right? I have 155.5. How many bags am I going to need? And what are you going to end up doing? 50x, divide both sides by 50. Okay, so that's an instance where you'd have to divide. Good question. Others? I'm going to do one more with you, and the rest are on your own or in your group with somebody in your group. We're not moving around here. Go to D, letter D. Go ahead and label your segments that I provide for you, G, B, M, H, and HT. And I need your help finding the area of MBATH. Basically the shaded region. All right, find me the area of the shaded region. How about a plan to find the shaded region? Do this, take these two and do this to them. What's a plan to find the shaded region? Here you go, 3. Got a plan, Emma? Stop. All right, let's do that. She said find the area of the rectangle. What are the length and width of my rectangle here? 10. 6 times 15. So the rectangle's got an area of, what was that, 90 spot? All right. What do I do from here now? You want to keep going, Emma? Sorry. Okay, there's 2 here. Do you want me to do the full one or the 2 separate ones? Okay, everyone, stop. She said the full one. That's the only way to do it. Because if you try to find the area of each one, I have no idea what MG is, and I have no idea what GA is. So we cannot find the individual triangles. It's got to be full triangle. Yep, so it's going to be the minus the area of the full triangle. And some of you would have noticed that. That's why I wanted to do it with you. You cannot find the area of each triangle. It's got to be the full one. What's your area formula for a triangle? 9, you're up. Area formula for a triangle? 1/2 BH. How about the base and the height of that triangle then? You're up. 6. Base and height of that triangle? 15 is the base, and the height we already labeled as? You got it. 4.6. I'll let you, and we already said we're going to subtract it. Never mind. So I'll let you guys calculate that. Looks like they're rounding to the nearest tenth. When you're ready, 11, let me know. Nearest tenth, what's the area of that shaded region? 55.5. Nice job. So you guys have B, C, and E. Do not raise your hand. I'll just come around and check as you're working. Okay, I'll come around and check as you're working. So you guys have B, C, and E right now.